right. Welcome to today's webinar out of a whole series of F&B Tech Talks. In today's webinar, we will talk about our scalable predictive maintenance solutions and how they can help you detect potential issues in your plant before they even occur. Thank you for joining us today. My name is Franziska Heinze. I'm working at Siemens and I'm guiding you through today's webinar in the background. In the virtual room with me are my dear colleagues, Michael Cora and Andreas Detmer. They are the experts from Siemens and will give you insights on our scalable solutions. Before we begin though, I would like to give you a short introduction into the webinar platform. We encourage you to submit questions at any time throughout today's presentation using the question box in the top right corner of your screen. We will do our very best to answer as many questions as possible at the end of today's presentation. During the webinar, we will also conduct 4 short surveys, and these will also be displayed in the upper right corner of your screen. Today's webinar will be available on demand after the webinar and will be accessible through the same URL you're on right now. And with that said, I would like to hand over to Andreas.
Yeah, thank you, Franziska. My name is Andreas Detmer, and I'm responsible for the business development of Senseye, or of our product Senseye, in the Central European region. Since predictive maintenance is a possible maintenance strategy, we have the right products to implement this strategy. Today, we will present you 2 of them, SCM IQ and Senseye. But first, a little background on predictive maintenance. Why predictive maintenance is important for the food and bev industry. So we can reduce unplanned machine downtime up to 50%. We can for sure increase the maintenance staff productivity up to 55%. And we then can also reduce maintenance costs, but also improvement in downtime forecasting. It is estimated that unplanned downtime costs manufacturers up to 50 billion per year. What does predictive maintenance actually do? We can detect early failures, anomalies, deviations, also trends, and then avoid these unplanned downtimes. We can also compare different condition indicators from different equipments and locations, and early error recognition. So this goes into transparency. Planning is a topic, and also optimization, setup time, and better production planning. There are solutions that allows companies to get quickly started. From the bottom, we can connect and monitor. So first, we can integrate new and existing assets and sensors into your system or into the PDM system, and then we can continuously monitor these assets. And after that, we can analyze and predict, or we can analyze the data and then do our predictions like trends, anomalies, degradations. And after that, it goes into digitalization and transformation, develop new products on this, new services, new business models on this, and transform into digitalization. Nope, this is too fast. Now, I would like to hand over to my colleague Michael for the presentation of SCM IQ.
Thank you very much, Andreas. A warm good morning, good afternoon to everyone from my side who's joining in today. I would like to take you through one of these portfolio elements that Andreas mentioned today, Citron's SCM IQ. Maybe to start off with a little bit on what is in the name, where does the name come from? So Citron's actually stands for Siemens Transmitters, and maybe some of you are already familiar that we have quite a comprehensive portfolio of sensors and transmitters, so starting from flow meters, pressure, temperature level devices, and so on. And this solution belongs to the same family of these sensors and transmitters, which is why we have the Citron's prefix, and SCM of course stands for Smart Condition Monitoring. And with that, of course, with this solution, our key goal is to enable you and your customers to improve the transparency on the health status of your assets, to effectively manage your assets better, to improve your maintenance planning, and able to enable you to do this. So before I get into the solution itself, I would like to maybe first spend some words on condition monitoring in general. So condition monitoring is not a new topic. Yeah, it's been around for sure for longer than I've been alive. And yeah, traditionally, it's always been KPI based. What this means is you traditionally assign limits or threshold to specific asset variables. If you cross this limit, you received an alarm or anomaly. This is how it was always done, but there are certain challenges or limitations when it comes to this approach. For one, you need to have deep expertise on every single asset that's out there in the field, which we know is becoming quite a difficult topic on its own in today's world. Second, it doesn't really compensate for the different operational states of the asset. So what I mean with that is, with KPI-based, normally it's a static threshold, but your threshold is never static across the different operational states. Your threshold is not the same if you have your asset running at 10% and your asset running at 100%. So it's not as accurate then to have this static KPI-based approach. And this is why when we decided to get into condition monitoring, we wanted to overcome all of these challenges. We wanted to take a different route. We wanted to utilize the technological advancements that have been there around us. And we took the AI-based approach to condition monitoring. And what we do here is we employ machine learning-based algorithms, and we analyze the raw vibration data that's being generated. And as a first step, we need to teach the system or provide the system a good operational state. So we need to teach the system what's the good state of the asset, and then the algorithms in the cloud are then analyzing this data that's coming in to provide you really data-driven operational insights to enable you to make a better decision making. So that's the approach that we take with the solution of Citron's SCM IQ for condition monitoring. And now let's have a look on the solution itself. So SCM IQ is an end-to-end solution, which means on the field level, we have the vibration and temperature sensors. Those are the small black things that you see at the bottom of your screen. So it's called MS200, so multi-sensor 200. They measure vibration and temperature. They're completely wireless sensors, so they transmit the data via low energy Bluetooth to the gateway that you see in the middle, Citron's CC220, so Cloud Connect 220. Each gateway has the capability to connect up to 12 multi-sensors, so you can have up to 12 multi-sensors connected onto one single gateway. The gateway then needs a wired Ethernet connection, using which then it transmits the data onto Insights Hub, the Siemens cloud platform that we have via MQTT. And this is also where, of course, our application layer of SCM IQ is then hosted. As well, the story of SCM IQ is not limited to just the data that's coming in from the vibration sensors, the MS200, but as well we have the capability to also integrate any additional asset variables or process variables that you have in the field into SCM IQ for anomaly detection. So we're talking about, maybe with the example of variables like current, voltage, maybe pressure in certain cases. So really, whatever variable could provide you additional benefit for condition monitoring, for anomaly detection, we are also able to integrate these variables into the same solution over here. Yeah, and with that, let's maybe look a bit into what's in the sensor, the Citron's MS200. So it's quite a rugged sensor. It's IP69 certified, so it has an exchangeable battery. As I mentioned, it's completely wireless, so it works on a battery which is completely exchangeable, as mentioned. So that's also great from a sustainability perspective, that you don't have to throw away the sensor once its lifetime is over. You can easily just replace the battery. It has a built-in temperature sensor from -30 to 80 degrees. And at the core of it, of course, it's a vibration sensor. So a 3-axis vibration sensor measuring from 13 to 3.3 kilohertz. And now I would like to maybe raise a short question as a poll to all of you in the audience. Yeah, did you face challenges in your customers' plants where vibration sensors could help you in improving transparency of asset condition? And I can see most of you have had these challenges in your experience, and this is exactly what we want to try and tackle with the solutions that we have that we're showing you today. So, and on that front, yeah, so maybe there are some of you who still have not maybe faced these challenges in the field. So I wanted to give you at least some examples on where these fit in. So the first one is actually from one of our manufacturing facilities to also show you the fact that we walk the talk. Yeah, so we actually do use or try to make the maximum benefit and value out of our solutions, even for our production facilities. So this is from our manufacturing site in Hagenau, where various sensors and transmitters are manufactured, and we install the system on the calibration bench. So we have a calibration bench where, yeah, it's part of the calibration process for flow meters. So it's definitely a critical process, because if we have a downtime there, we are not able to complete the calibration process, which means then we are not able to deliver the flow meters in time to all of you as our customers. So we use the system there on 8 75 kilowatt pumps. And really, I think it was in the 3rd month already, we were able to detect an anomaly and able to enable, or let's say, have the necessary maintenance planning prepared so that we are able to avoid any unplanned downtime. So the return of invest is also quite fast with such a solution. Even one downtime you're able to avoid is already savings in terms of both cost and time is quite massive. And with that, I would like to now take you directly into the live system that I would like to show you today. Give me a minute. So this is the initial dashboard for Insights Hub. So of course, you can subscribe to various applications, and then you would see all of them over here. But the focus today is Citron's SCM IQ. So I'm going to click on that, and then give it a minute. It should load up. So on the home screen, of course, of SCM IQ, you can see a general plant overview, how many gateways are connected, how many sensors are connected, how many models are running. I will show you a bit later what this means. A bit more of the audit trail. So were there any assets going offline, any sensors going offline, and so on. And if I go one step further into the device configuration tab, this is where I would, yeah, you can also see the different list of the gateways that are connected, how many sensors are connected to each gateway, and also a comprehensive list of all the different sensors that are online, offline, what is the status, what is the signal strength, and so on. And now I would also like to show you, I mentioned, so we want to keep it easy. So this is a generic anomaly detection solution. So it's pretty much working out of the box, and it's also very easy to set up. And what do I mean by easy? So if you want to add a new sensor onto the system, all you need to do is press on connect a device. I say connect a sensor. I need to select, of course, which gateway I want to connect it to. And then if I press next, all I need to enter now is the MAC ID on for each sensor. This you can see on the right is is on the label of the sensor itself. So you can just read it out from there and enter the MAC ID over there, enter whatever name you would like to assign to your sensor, and then that's it. And then you save, and then your sensor is onboarded in a minute to two. Yeah. So it's very easy to onboard the system, to set up the system. Commissioning is, you don't need any expert IT knowledge or vibration knowledge. It's really quite intuitive user interface over here. And so once you have the sensor connected, of course, I mentioned the first step of our solution is that we need to teach the system what's the good operational state. And here what you need to do is once the sensor is connected, typically you need to let it run for a period of maybe 2 to 4 weeks, depending on the application, with the goal in mind to collect all the different operational states of the asset. Yeah, so asset at maybe pump at 20%, 50%, 80%. So we want to collect all of the different operational states. And then once we have that, what I can show you is, so let's take a bit more data. Oops, let's take another asset, sorry. Just give it a minute. So this that it should come up. So we have the 3 axes of vibration. Temperature data is also available. So I would maybe, just to provide you a better example, take the 1 month data so you can see a bit more of the vibration data that's coming in and how it's visualized. Yeah. So once you let the system run for a period of 2 to 4 weeks, we are now ready to train a model. So we want to train a new model. We want to teach the system what's the good state of the asset. So I can give the model any name that I would like, and then I select the time period that I would like to use to train the model. And then now what I need to do is I need to select the good states of the asset. So if you had any downtimes in between, if you had any maintenance intervals in between, all of this needs to be excluded. So I would only select the good states of the asset. So with the example, maybe I select all of this. I say 1, 2, 3, 4. These are the states that I would like to teach the system, teach the AI that this is the normal operational state. I can we also have a field called training optimization, with which it also then filters out the idle states a bit. So really to take only the applicable data, the valuable data, and ignore the idle states a bit. Yeah. So once that's done, all I need to do again is save and start training. And in a few minutes, then the system is ready. It's up and running. It's then, analyzing the real-time data that's coming in from the sensors, comparing it to the patterns that you've taught it to be normal, and then providing you an anomaly whenever it detects a deviation. So there is no static threshold. It's really a dynamic pattern recognition that we are doing over here. And this enables you to have a more accurate, easy solution for condition monitoring. So that was a quick overview of the application itself. Hopefully that was helpful to have provide you a bit more insights into how the solution works. And one additional example I also wanted to give you, also from the food and beverage perspective, is we had with one of our customers install the system on a bottling line, on a syrup pump. So you can see with them, we try to work out what does it actually cost for each incident that they would have. And we try to work out, okay, that every incident that we are able to save with SCM IQ, we are able to save them around 5,200 euros approximately. And that's only the direct cost, but as well, there are additional other costs that are applicable. So the cost of repair of the asset itself, if it completely failed, additional emergency spare part delivery cost, and so on. So really, there are much more financial impact that these unplanned downtimes can create. Yeah, and also, we don't have enough time to go through all the different applications, but I just wanted to put some examples on one slide to say, really, we are asset agnostic, industry agnostic. So whatever assets that are out there, if they could benefit from condition monitoring based on vibration analysis, it, in most cases, is a perfect fit with SCM IQ. Yeah, and also at Siemens, the goal or the vision we have is not that we are developing individual standalone solutions. So it's really to leverage the whole ecosystem, to build up a whole ecosystem that can provide you additional benefits. So SCM IQ, as you saw, is a tool, a solution primarily for anomaly detection. But as well, maybe you have customers or you have applications where you would like to have additional insights. You would like to have maybe dashboards, additional threshold monitoring, KPI calculations, reporting functions, and so on. So all of this is as well possible using the ecosystem of Insights Hub, where we're able to easily add on and integrate other applications and functions as well on top of SCM IQ. All right. And one of the last slides from my side. So as well, ecosystem integration key, which is why it's not only limited to Insights Hub, the cloud ecosystem of Siemens, but as well, we have APIs that allow you to integrate into third-party systems as well. So you can see the some of the API, some of the data that is possible to be integrated. So the time series data for sure. This is the peak-to-peak values of the vibration data. Event management, so is your asset in alarm or a warning or error? So this is as well possible. All files that are stored on SCM IQ, so any pictures that you uploaded when an anomaly occurred, any data description that you put in when an anomaly occurred, all of this can as well be extracted into additional systems when necessary. Yeah, and with that, of course, that was a very quick overview of SCM IQ. Hope that was interesting for all of you, but as well, we have other complementary solutions from Siemens which fulfill this overall holistic view that we want to take with condition monitoring. And here I would like to hand over to Andreas, who's going to show us a bit about one of these complementary solutions, Senseye.
Yeah, thanks a lot, Michael. Thanks for the handover. Okay, let's take a look into Senseye. What is Senseye Predictive Maintenance? It's an automated asset intelligence and predictive maintenance software tools designed to meet the challenges of today. I think there is one topic in the middle. Let me see if I can highlight it. It's not addressing just only downtime. We addressing maintaining uptime. So you want to have not this reactive maintenance. So when an asset fails and everybody is running to these assets, so really this unplanned downtime, we want to avoid these unplanned downtime, but also a lot of our customers have this preventive maintenance. So change an asset every 2 weeks, every 4 weeks, and even if the asset can run for more than 4 months or 4 years. So we want to do precise and correct maintenance really when it matters. So when the asset has a problem, then go to this asset and maintain this asset. This results in reducing risks and operating costs, and we are a cloud platform, so remote work is supported, and for sure sustainability is also a topic with Senseye. So we want to avoid waste. So this changing assets every 2 or 4 weeks, which is not needed. So try to avoid these waste, this unnecessary changes of the assets. This goes into the sustainability topic. To be honest, focus is for sure these 2 topics: maintaining uptime and do precise and correct maintenance on the assets. That's the core topic, I think, or the 2 core topics. What we are monitoring. So while the SCM IQ system from Michael is a complete package. So you have the sensors, the gateways, and so on, and the application. Senseye is sensor, machine, and industry agnostic, like SCM IQ. We don't care about the industry. So if you are working in food and bev, or we can work in food and bev, but we can also work in steel, chemical, and so on. And Senseye is looking at all assets within your production that are critical, and we can monitor a lot of assets like motors, pumps, fans, conveyors that are typical assets within the food and bev industry, for sure. Mixers, bucket elevators, also chillers, or the opposite, the heaters are also classic assets for us that we can monitor, but also complex assets like AGVs, or if you have an automated warehouse, we can monitor the stacker cranes. If you have, it's more in food and bev at the packaging area, when you have robots, something like that, we can monitor the axis on these assets. Overall, Senseye, or with Senseye, we already have monitored over 100 different types of assets in different industries, different verticals. So that's the assets we are aiming for, the real critical assets within your production. With Senseye, you don't need you not really need a data scientist to set up the project or to train a model or something like that. Senseye will do it for you. So when the data is streaming to Senseye, to the platform, typical condition monitoring data, pressure, current, torque, vibration, but also possible data could be temperature, also opening and closing times from valves could also be condition indicators for us. And then we can also add a bit of operating context, like what speed is running on this machine, which receive is currently running on this machine. Is this ramp up phase, or is the motor starting? All this goes into the Senseye AI, and then Senseye try to learn the normal behavior of this asset. And after a while, Senseye thinks, okay, now I have seen everything under normal circumstances, and I go out from the training mode into operate mode, and then I try to find anomalies, trends, degradations, and so on. So compare what Senseye has learned with the live data, so what's coming in, and then inform the maintenance crew, okay, here's something going on, please take a look at these assets at the moment. How does a success case within the food industry looks like with Senseye? So in the food and bev industry, we had a success case at the pump, for example. The bearings reached end of life, and I don't know if it's good to see in the webinar and the presentation, but Senseye detected we had vibration data from this pump, and we detected mid-January a trend in the vibration, and the customer worked on the asset or replaced the asset mid-March. So this is the time span which is normal. So detect pretty early that something is going on at this pump, but you have time. You don't have to work on this asset now. Plan the maintenance job, the work order within your shifts, and you have time. This pump runs over the whole time pretty normal, and then it was replaced 2 months after the first detection. So this is a normal case with Senseye. So you don't have to run directly to the pump when the case is open. Look at it. Senseye also, we see that in the application. Senseye also give you a little bit of guidance. So what has high priority, what has low priority. That's what Senseye is doing. In the end, the customer avoided up to 200,000 euros of follow-up damage. So the pump was not completely damaged, could be repaired. The product was not damaged. There was no unplanned downtime. The pump was changed within a maintenance shift, a planned maintenance shift. So that's a bit of outcome or what Senseye can do for you as a customer. And this is only one success case on one pump, and you can scale about your whole factory with Senseye. Now we can take a look into the live demo. I hope you see my the web page. So the maintenance crew can log into their account. It's available everywhere on your tablet, on your mobile phone, and for sure also in the normal browser. So you can log in And what you see, we have a demo account here, and on the top, you have then the hierarchy of your plant, of your production, and you can go deeper into your production. So we go into Victor Global, our awesome company, which produce everything from oil, gas, heavy industry, pharma, and so on, and also FMCG. And then you can simply go deeper and deeper into your production. And on the left side, you see how many cases are currently opened at this area. A case is a prediction, so like anomaly, trends, and so on. So when Senseye detects something, you see this as a case here. And I close this a bit so that we have see more here. So for example, when we have here conveyor, we have a trend here at the conveyor. You see also the colors. So red is the one you should look at it, and then orange, yellow. So Senseye guide you where to look at first. So, but I took this trend, this conveyor, for example, and then we have the case overview and our Copilot. We have our Gen AI integrated. Our Copilot tells us what happens. So there's a rising trend on the motor temperature on this conveyor drive starting 19 days ago. Here we see the raw data. Yeah, we see there's a trend. And then Senseye also suggests some possible explanations. Increased load, the rising trend in motor temp could be due to an increased load on the conveyor drive. Yeah, this could be. Or there's a cooling system issue maybe, or mechanical wear. So if this is not enough for me, then I can also talk with Senseye. So it's a classic Copilot, as we all know now from ChatGPT and so on. The Copilot rely on the data that comes in from the maintenance crew when they work on the cases, but also now you can upload documents like FAQs and so on, so that the Copilot can maybe also get information out of that. And what the maintenance crew is then doing, look at the case, what is happening, maybe talk with the production, and maybe they can say, nah, this is not a real case. No reason for case. This is normal behavior. They can put in some notes for that. This goes also directly into the Copilot as information, and then the case is closed because not every prediction is maybe a real prediction or a real trend. Maybe the production tries something different, and there Senseye raise the case. But then Senseye learns from the feedback and will not raise again a case with a similar trend on this asset. But for sure, we want to have good predictions, and then the maintenance crew can add their work, what they have done. So adding this work event. So what was it? Non-routine because it comes from Senseye. I've repaired the asset. Maybe this conveyor was a bit blocked, or the fan was blocked. If I replace the asset, maybe a relearning is not so bad. So as I said in the beginning, no data scientist is needed here to train a network or something like that. So Senseye will do this all for you. So you can apply relearning, and also you enter time spent on activity. Avoid downtime for sure is a bit of what if this pump or this conveyor fails. And then maintenance crew simply close this or save this work event, and then can close the case. Potential breakdown avoided. Bit of background also, as said, goes into the Gen AI from us to have better suggestions at newer cases. Then close the case and work on the next case. So what Senseye is doing, take the data from the assets, do good predictions, and guide the maintenance crew what to do next. So don't work on assets that need no currently nothing, or assets that need no maintenance at the moment. So really work on that, what is currently important. Okay, so that was Senseye in a nutshell. And I think maybe I have also a slide after this. I have the Q&A slide. Okay. Okay.
Yes.
Then let's see, Michael.
So thank you all for your great presentations.